Welcome back to my third lecture on power transmission. In this lecture, we are going to cover the different kind of gears and the gear transmission. So till now, we have studied the rope drive, belt drives, and chain drives. So we all know that the limitation of rope drive and belt drive is the slip condition, and we are bound to transfer a certain amount of power only by using belt drive and rope drive. We also use such kind of arrangement that is friction drive. Here what happens, the driving wheel drives the driven wheel with the help of the friction in between the surface. But here also, if we want to transmit high power, the slip may occur. And to avoid such condition, we use uh, gear drive. And a gear is nothing but a combination of recesses and the projection surface on different discs. So you can read these lines in order to transmit a definite power from one shaft to another shaft to the projection on one disk and recesses on another disk can be made which can mesh each other. This leads to the formation of teeth on both disks, and discs with teeth on their periphery are known as gears. So this is the basically very crude definition of a gear. So what we say here, projection, that means the protruded part is projection, and the empty part, the groups are here recesses, and the combination of this is gear, the gear mechanism. And now, what are the advantages of this gear and what are the disadvantages of these gears? So first major advantage of using gear transmission is to avoid slip condition. Since we have grooves and protruded parts, so there is no chance of any slip, and the velocity ratio is fixed here. You can fix the velocity ratio. That is also a major benefit of using gear mechanism. It can transmit very large power, okay, high transmission efficiency because there is no lashback, and required less space, reliable source. What are the disadvantages of this gear mechanism? Since the process of manufacturing gear is high, so the the initial production cost of gear is high. So this is a one of the disadvantages of gear drive. Maintenance should be required here. We need lubricant for using on daily basis. We need lubrication in the gear mechanism, and if somehow any mistake happens during the manufacturing of the gear, then we will not able to use that gear for a particular velocity ratio or a particular arrangement. The number of tooths, the depth, everything, all parameters should be in the correct order. So these are the drawbacks of using gear drives. Now we are going to correlate and study what are the different terminology used in gears. So one by one, I'm going to define and explain this thing. So this is a portion of gear, that is a two-third portion of one gear, and here we can understand what is the pitch circle and other parameters. The first one is pitch circle. So pitch circle is nothing but an imaginary circle by which pure rolling action would give the same motion as the actual gear. Here, what happens when one gear messes with the other gear? So when gear starts rotating, a rolling used to happen at the point of contact, and the pitch circle represent the same nature of rolling motion by a imaginary circle. So this imaginary circle by which we can obtain the same rolling condition as we achieve by using the real gear is called pitch circle. Now what is the pitch circle diameter? Pitch circle diameter is the diameter of this pitch circle. Okay, and usually the size of gears are defined by this pitch circle diameter only. Now what is pressure angle or angle of obliquity? So this can be defined by when two gear messes together, then there is a common point of the teeth. Okay, so The common normal of the common point of teeth here written as it written here, and the tangent of common point of their pitch circle. Now try to understand, when two gears used to mesh, there is a point where teeth will match the other teeth. So at that point there would be a common normal. Okay. Second thing, when two gear meshes, there will be intersection part of pitch of their pitch circle. So at that point there would be a tangent. So between the tangent and the normal, the common normal, there would be some angle, and that angle is termed as pressure angle. So you don't need to go very deep into this. You need to only understand what these properties are, and we don't have to study it so deep in this unit. So you should have only a little bit knowledge about the parameters only. Now, what is pitch circle? So pitch circle is a distance measured on the circumference between the two consecutive teeth. So the definition is it is distance measured on the circumference of the pitch circle. Remember the pitch circle from a point of one tooth to the corresponding point on the next tooth. What the meaning of this corresponding point? Corresponding point means if you consider the point here, so the corresponding point of this position on other teeth would be this point. Okay, so this is the meaning of corresponding point. So we know the circumference would be pi d, and if we have t number of teeth, then the circular pitch would be pi d upon t. Now, what is module? Module is a ratio, and it is a ratio of pitch circle diameter in millimeters to the number of teeth. So these are the terms, basic terms, which terminology which is used in gear. Now the classification of gears. Actually, we can classify gears by using different conditions, but here we are focusing only on the basis of the shaft arrangement. Okay, so classification of gears according to the shaft axis. So first condition will be parallel shaft, intersecting shaft, and non-parallel, non-intersecting shaft. Now try to understand what this parallel shaft means, what this intersecting shaft means, and what this non-parallel and non-intersecting shaft means. So in gears, what happens? One is driving gear, other is driven gear. So if the arrangement of gear shaft, you understand that gear would be mounted over a shaft, right? So if the shaft on which the gear is mounted, the both gears, the driven gear and the driving gear, if their shafts are in parallel condition, so it would come in this category. And now again, if their shafts are intersecting in nature, then the gears will come in this category, and these are the example of this intersecting shaft gears. Now non-parallel, non-intersecting. If the you can say the shaft are on different plane and they are not parallel and not intersecting, then the gears which comes into this category are uh, spiral gears and worm gears. So we are going to see the diagram of these different gears and try to understand this parallel, intersecting, and non-parallel shaft gears. So now I start with the spur gear. So here you can see this is the firstly let me explain you what is spur gear. So spur gear is what? When the axes of two shafts are parallel to each other, these gears have teeth parallel to the axis of the shaft, right? So this kind of arrangement is known as spur gear. So the smaller one is called the pinion, and the bigger one is called wheel. Okay. Now see, the pinion has this shaft, and the wheel has this shaft. Now you can see the shafts are parallel. So this spur gear comes in parallel shaft gears. Now the helical gear. So in helical gears, what happens? The teeth are at some angle called helix angle with respect to axis of the shaft. and this can be of two type. You can see here the helix angle is in single direction only, but you can see here the helix angle in both direction. So it is called the double helix gear. It is called the single helix gear. So you can say single helix gear simply. So now what is difference between this spur gear and this helix gear? Because their axes or the shaft axes are parallel. In both cases, shaft axes are parallel. So here what happens in case of helix gear, the arrangement of the teeth comes very gradually. So this you can see very less noise here and very smooth power transmission. But in case of spur gear, you can hear noises and there is no very smooth power transmission here. So this is the basic difference between helical and spur gear. Okay. Now the next one, rack and pinion. So what is rack and pinion? This is a special case of spur gear in which one gear is having infinite diameter called rack. So this is the example app, rack and pinion gear. So what is the meaning of this infinite dia? So see, the lower portion is a straight line, and on that straight line there is a plate, and over that plate the toothed mechanism is there, and grooves are there. So if there is a parallel line, we can consider that the diameter of that parallel line, if we consider that parallel line as a portion of a circle, then the diameter of that circle would be infinity. That's why it is almost a straight line. So that's what written here. Now the circular part is pinion and the straight part is rack. And this mechanism basically used in many kind of machines, many kind of machineries. In our lathe machines also we use such kind of mechanism, rack and pinion mechanism. Now here also you can say, and this rack and pinion gear comes into category of the parallel shaft, right? Now the bevel gear. So these are the arrangement of straight bevel gear. What is straight bevel gear? If the tooth are parallel with the shaft, then this is called as straight bevel gear. If tooth are not parallel like this, the spiral tooth are in nature of spiral, then it is called spiral bevel gears. So the application of this bevel gears are the best example is the differential gear that are used in automobiles. So these are the example of intersecting shaft. You can see uh, here the shaft direction is like this, and the other pinion portion, the shaft direction is like this. So you can see the shaft will intersect. Like here you can see this shaft along the x-axis, this shaft along the y-axis, and this will intersect at some point. So this kind of gears comes into category of intersecting shaft category. Now the spiral gears. So these kind of gears comes into category that is the third category, non-parallel, non-intersecting. So you can see the direction of this shaft is here in this direction, or you can say x direction, and the other shaft position is like it is on a different plane, and the direction is also different. So this shaft will never intersect. So these kind of gears comes into category, which is what do you say, the non-parallel, not non-intersecting gears. So here also uh, the spiral conditions are here, so the power transmission would be very smooth here. But the major drawback is we can transmit only less amount of power here because there is a point contact in between these kind of gears. Now the last one, that is worm and worm gear. So this is the worm and this is the worm wheel. This is also used where we need high torque transmission. We need to calculate very easily along with the process the speed. Then we use such kind of mechanism. This is used in many machinery. You can say that like elevator, guitar, and many other components have such kind of arrangement. So these are the different kind of gears, and we came to know about the basics of gear transmission. So this was the whole introductory part of this unit 4, and in unit 4 we need to know about only transmission, and we have covered up all the portion like the belt drive, the chain drive, the rope drive, and the gear drive and types of gears. So this was the whole syllabus of fourth unit, and now we will start fifth or sixth unit all together. And we have some numerical problems also in this unit 4. So I'll upload a video on that is a tuned video in which I'll discuss some questions. I'll try to discuss some previous year question. It would help for you, very helpful for you. So be in touch, and thank you.